Okay, hi everyone. Yeah, let's just wait for 2 more minutes and then we'll start. Right. So if you all have any doubts, yeah, keep all of that ready. We'll start in 2 minutes. All right, everyone. Welcome to the open session. Yeah, so we will be discussing about week 8. Uh, yeah, so any general feedback about week 8? How is it going? I hope all of you have gone through the lectures. Uh, yeah, anything which you want to share? Okay, how have all of you watched the lectures? Okay, okay, let's start with doubts then, right? So, you can let me know, yeah, your doubts one by one. I'll note it down and then we'll see what we can do in today's session. Yeah, let me just start sharing my screen. Yeah, just give me a moment. Okay, share. All right. Yes, week 8. Yeah, if any of you have any doubts, you can unmute and uh, we can talk about it. Yeah. Any doubts? No doubts? Okay. Closest pair. Okay. Any particular question in that or the algorithm in general? All right. Okay. Median of median and complexity. Okay. Specifically the complexity. Karatsuba's algorithm. Uh, Aditi, any specific doubt in Karatsuba? Okay. Okay. Let's start off with this, right? Uh, okay. Let's start with the closest pair problem. So I hope all of you have seen the lectures. Let's see where is, yeah, all right. Yeah, yeah. So, in week 8, as you all know, we are going to, we have looked at an algorithm strategy known as divide and conquer, right? As opposed to the previous week where we looked at greedy algorithms, where we were given a problem. Uh, at a particular moment, we took a local decision based on some parameter, right? It can be the shortest distance, it can be uh, the fastest finishing time, or sorry, earliest finishing time. So based on some criteria, we took a local decision, and then we later came to know that, and we later through a proof proved that that local decision which we made at each step, right? That indeed is the optimal solution, right? And in divide and conquer, it's a little different, right? What we do is we have a big problem, and instead of solving that big problem, we divide it into parts. Then we keep on dividing it until we reach the base case or the smallest such task, and we solve that task. And then we gradually build up and solve the entire problem, right? And many of you are familiar with uh, uh, like we have looked at many divide and conquer uh, algorithms previously, right? The most common one being merge sort, right? So in this algorithm, the closest pair of points. So basically, let's say you have, yeah, right? So let's say you have, this is the y-axis, this is the x-axis. You have different points here, and each of them have an x and a y coordinate, right? So let's say this is 1 comma 2, this is say 2 comma 4, this is say 7 comma 3, right? And let's say, yeah, so this is say 6 comma 5, right? Now you have n such points here, and you want to find the pair of points which are closest to each other, right? And by closest, we know we calculate the distance or the Euclidean distance, which is square root of uh, the x coordinates minus the y coordinates, right? So yeah, so that is the algorithm. I mean, that is the problem, right? So what we do, yeah, and the naive algorithm is, you know, just look at this point, compute all the distances, then look at the next point, compute all the distances. So it is by doing two scans across all the points, right? You can do it, right? So in the divide and conquer strategy, what we do is, yeah, so all this we know what it is. So yeah, I'll skip all of this. Yeah. So the strategy is, right? So let's say you have n points, right? And you what you try to do is divide this entire plane, right, into two parts, right? So for example, you divide this into something such that there are, roughly equal number of points on the left and on the right, right? And then you do this recursively. Then again, you split this into two, then again split it into two until you get, right, 2 points. And it's easy to calculate the distance between 2 points. No, I think the base case is, let's say we have 3 points, then it's easy to calculate the distance between 3 points, right? So, yeah, so we continue doing this until, right, we get 3 points and we calculate some distance d, right? And then we, combine or we merge these regions together, and collectively we compare the distances and we find out the minimum distance, right? So before that, what we do, yeah. So how we actually go about doing that is, first of all, yeah. So uh, we have these points, right? P1, P2, up to Pn. So first we sort Px. So we take these points and then we create two sets, right? Px and Py, right? And Px, P is sorted by the x coordinate. Px is all the points such that it is sorted by the x coordinate. So for example, in this case, you know, we'll go from left to right, right? So we'll go like this. So this will be the first point. Then maybe let's say this is the second point. This is the third point, fourth point, and so on, right? And Py is we are sorting by the y coordinate. So we're sorting in this direction, right? So which will be the first element in Py? Will it be this? or will it be this, or will it be something else? So let's say this is A, this is B. Which do you think will be the uh, first point in Py, A or B?
B.
Okay, Shamit is saying A, Prajwalit, Sharbarish is saying B. Okay, so yeah, in a way it depends. It depends on where your axis is starting. Yeah, sorted by in the increasing order, right? And usually our axis starts from here, right? So this will be 0, 1, 2, 3 all the way here. So in that case, right, B will be the first one, right? All right. Yeah. So after we do that, right, we divide P by a vertical line, right, into equal sizes Q and R, right? And now that's easy to do, right? We have to just, uh, since it's already sorted, we go to the middle element in PX, right? And that becomes, oh yeah, and then we can get Q and R, right? Now to get, now we need QX, RX, QY, RY, right? So now for both of this we need, so remember what is QX? QX is Q's sorted by the X coordinate, right? And QY is Q sorted by the, so QX is Q sorted and QY is Q sorted by the Y coordinate, right? Now getting the QX and the RX is easy, right? Why? Because we have already divided, or we have taken P, like we have divided it based on the x-axis, right? So equal number of points are there on the left and on the right, right? So we can so all the points to the left of this line, okay, whichever point this is, right? We can consider them in QX, right? And all the points to the right of P, we can consider them in Rx, right? Any doubts there? Okay. Now the tricky part is in calculating Qy and Ry, right? So let's take an example. Now, so let's say this is 1, this is 2, based on the uh, X sorting, right? Qx, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right? Now dividing So this was our initial set of points, P, right? Now what we did is, now we have to divide them into Q and R, and each Q should have two sets, QX and QY, and E in R should have two sets, RX and RY, right? Now, dividing or getting QX is easy because what we have to do in P, this line, right, which divides, sorry, this, so this partition, as you can see, right, it divides it into 10 on the left and 10 on the right, right? So we have to just look at the first 10 elements, right? That will be QX, and the next 10 elements, right? That will be RX. Right. Now, if you wanted to sort them according to the y coordinate, right? Then, as we said, right, this thing, sorry, this thing over here, this would be 1, this would be 2, this would be 3, this would be 4, right? So we can't say that, okay, 1 to 10 will be, uh, in QY and 11 to 20 will be in RY. That's not possible. No, see, here also, if you see, 1, 2 is actually in RY, and 3, 4 is actually in QY, not in RY. Or, yeah, right? So we have to do something else, right? So let's say in order to calculate QY, what we have to do, or RY for it in that matter, right? Take the points in PY, okay? Take the points in PY. Okay, let's say we'll take the first point. Remember that point will have the x coordinate also, right? That x coordinate we compare with, our line coordinate. If it is greater than that, then we know this point will belong to RY. If it is less than that, let's say in this case, right, that will belong to QY. So in one scan, right, we are able to get QY and RY also. Any doubts in this? How I calculated PX, PY, sorry, QX, RX, and QY, RY? Any doubts in that?
Sir, could you repeat about QY and RY? How
Yeah,
to
yeah, sure.
calculate?
Yeah, sure. Maybe let's take an example. Maybe that might help. So let's say, okay, so let's take our coordinates like this, right? So 1, 2, 3, 4. Okay, Bipin is asking, just to confirm, same set of points go to QX, RX, and QY, RY. Same set of points as in Bipin, can you elaborate? What do you mean by that?
Yeah. So I just want to ask, so all the points that are on the left of the axis, on the left of the line, so they all go to the are two sets of, right? I mean QX, QY and
And
RX. Sorry, yeah.
yes, correct, correct,
I mean there is no Y axis as such. It's just the X axis that we are differentiating on.
correct, correct,
Okay.
correct. Yes. All right. Okay. Let's start with, let's say, 8 points, right? Can you all tell me some points? I'll mark it down here. Anything? Any 8 points? Let's say in this. Okay, 2,3, 5,7, 2,3, 5,7 is somewhere here. Okay. Okay. 2,3, 5,7, 3,4. Yeah. So remember, sir said in the lectures that, for simplicity, we have not taken points with the same x coordinate, right? So let's just keep it that way because I don't want to complicate things. 1, 2, 3, 4, 5. Right? 2,3, 5,7, 3,4, 0,5. Okay. Okay. Let's we won't. Yeah. Let's try with these points, right? So now P is this set, right? Now what I will do is I will calculate P of X. Okay. Px is the same set of points, but it is sorted according to the x coordinate, right? So, which will be the first element here?
Zero comma 5.
Right? Straightforward, right? 0,5. So you do a scan like this. So you see 0, 5, 1, 1, 2, 3, 3, 4, 5, 7. Similarly, you do a scan from bottom to top. So first, what do you see? You see 1, 1. Then you see 2, 3. Then you see 3, 4. Then you see 0, 5. Then you see 5, 7. Right? So 0, 1, 2, 3, 5. 1, 2, 3, sorry, 1, 3, 4, 5, 7, right? So Px and Py are sorted according to x and y coordinates respectively, right? And now we divide them based on, okay, we draw a line like this, right? And essentially we are dividing. So intuitively here you can see there are like 1, 2, 3, 4, 5 points, right? So yeah, maybe you can divide it something like this, right? So you take uh, uh, yeah, so maybe we can divide it somewhere here, right? This is the line. So we divide it somewhere over here, right? And what we say is that now this part becomes Q and this part becomes R, right? And now we have to follow the same procedure here as well. Okay. we have to calculate qx, right? Rx, qy, ry, right? Now from this, calculating qx is easy because we know that the line is somewhere, let's say this is x is equal to 2.5, like whatever, right? Or, okay, I don't want to complicate that. What we have to do is just look at, this is 0, 1, 2, 3, 4, right? Or the length of this is 5, right? So 5 divided by 2. So we take the third one, right? Maybe include this in left also. So this will be in QX, right? And this will be in RX, right? That is straightforward, right? So 0, 5, 1, 1, 2, 3, right? It will be in 1. And QY, sorry, RX will be 3, 4, and 5. Now, PY we cannot divide it like that, right? Because see, if 1, 1, 2, 3, 1, 1 and 2, 3 are in Q, let's say the Q region itself. But look at 3, 4. 3, 4 is actually here. So there isn't a straightforward way to divide PY into QY and RY, right? Like how we did it for PX, divided it into QX and RX. So what we do is we look at each element in PY, right? And we know that our X is getting divided at 2, right? We look whether for this PY, okay, we look at the X coordinate and we check whether it is lesser than this or greater than this, lesser than or equal to 2, right? If it's lesser than or equal to 2, we know that this will belong to the left side, which is the QYth part, right? Is this clear? Any doubts here? Okay, so we know this will belong to Q1. Then the same strategy. Now the next element, we look at the X. Yes, it is less than or equal to 2, so this will also be here. Now this, the X is greater than 2, so it will belong to the RY. Again, 0 here and 5 here. Right? So now what we have done is, and we'll see that Qy is in the ascending order of the Y coordinate, 1, 3, 5, 4, 7, and Qx is in the ascending order of the X coordinate, right? 0, 1, 2, 3, 5. Right? Now we do this recursion, right? And what we said is we will look at 3 points. If a region has, or if a portion has only 3 points, right, we will do it manually because it won't take much time, right? So we can directly apply the distance formula and check the distance between, which of them is closest, right? Okay, so I won't apply the distance formula and all of that now, but let's assume this is the shortest distance in this region. Okay. Similarly, here we have only 2 points, so no, we know that this is the shortest distance. Okay, so let's take this hypothetically. I don't know what this will be, but let's take this. Let's take the distance of this as 2. And let's take the distance of this as 3. Okay. And now when we remember in merge sort or any divide and conquer, we divide the problem and then we have a combination phase where we combine the problem and find the final solution, right? So intuitively here, what do we do when we combine the solution? So remember, there could have been many other points. We would do this recursively and keep on combining them. And in the combination, what we have to do is check which of these are small, right? So in this case, we know that distance between 1, 1 and 2, 3 is smaller than the distance between 3, 4 and 5, 7, right? But there is one more thing which we need to take care of. And what is that? Something in this Q region, right? And something in the R region. The distance between those 2 points can be smaller than 2 or 3, right? The smallest in Q or the smallest in R. So we need to ensure that, or we need to check that as well, right? So for example, in this case, it could have been the case that, this distance, okay, this distance could have been 1.5, for example, right? So we need to consider that as well, right? Right. So, yeah, and there is a clever way to do it. So then you all might think, okay, so let's say, so then should I have to compare this with this, and then this with this, and this with this, and this with this? Then it looks like you're comparing all the points on the left with all the points on the right, right? And if it's like n by 2, n by 2, then again you're coming to an order of n square time, right? But there is a clever way to, minimize, or we need not do this pairwise comparison for all the points here, right? And yeah, so I'll just briefly explain what that is, right? And then we'll look at the slides also. So we know one thing, right? We know that we need to check the distances of points which are possibly lesser than the minimum of these two, which is lesser than 2 units, right? So it doesn't make sense for me to look at 1, 1 and look at 5, 7, because I definitely know that, they are uh, visually, right? Visually, we know that both the distance will be definitely greater than, right? Or maybe in that case, 2, 3 and 5, 7, right? But if we had some points here, right, which are closer to the separating line, those are the points which we need to check. Okay, is this clear? So for example, I'm just drawing some imaginary line here. Okay, it could be the case that this is less than 2. Okay, this can be 1.5. Okay, or let's say there can be yeah, let's add 2 more points here, right, which are there originally, right? Or let me take it. This is 1 point, right, which is okay further than these two, so that's why we didn't get that. And something over here, right, which is further away than these two, that's why we got this, right? Now, okay, intuitively, this is actually the closest pair of points, right? But we could not get that in our divide strategy. So when we combine them, we should check for these two. But I need not check this with this or this with this. Similarly, this with this or this with this, because I know that these distances, right, it is beyond some number, which is the minimum of these two. So what I do is I just have to create a band of, let's say, 2 and 2 units, right? Because my minimum is 2. Okay, draw a line over there. And check for all the points, check only for the points which are in this region. Okay. Is this much clear? Okay, to recap, I keep on dividing my space into left, right, right, until I get 3 elements or 3 points. And then I calculate the minimum distance. And then I combine 2 regions together, look at the minimum, right? But along with that, I should also check if there are 2 points which are on either region, but which are close to each other, like in this case, right? And the main point to note is that we need not check all the pairs of points on the left and the right to do that comparison. We need to just check pairs of points which are at a distance of 2 plus 2, okay, 4, right, from this point. And we'll go to the slides. In the slides, we will see that, there won't be many points over here. Okay, there is a constant number of points, right? And once we do that comparison, we'll realize that, okay, this is actually the shortest. Maybe this will be something like 1.5, for example. And we return 1.5 as the shortest distance between the pair of points. Okay, intuitively, I hope all of you have understood the algorithm. Any doubts in this? Any doubts in this? All right, let's go to the slide, right? So, yeah, this is what we did. We divided it into the left and the right. And yeah, the key point to note is all of this can be done in O of n, right? We just had to do one linear step, both for Qx, Rx, and Qy, Ry, both. Yeah, so we split that, and yeah. So this is the combination, right? We found, like how we found here, this 2 and this 3 as the minimum, right? Here we found dq and dr as the minimum in the Qth region, in the Q region and the R region respectively. But the possibility that there can be, yeah, and let's say that is delta, there can be 2 points, right, on one on Q and one in R, which are less than delta, right? And we need to consider those as well. Okay, and yeah, so okay, why delta? Yeah, let's say, yeah, yeah. Why not delta by 2? Okay, let's take this example. Okay, so let me just run this up a bit. Okay, so the question is, maybe let me just try this. So remember, we have a line like this over here, the Q and R regions, right? And we know that, so in this case, our delta is equal to 2, right? What is delta? Delta is the minimum of dq, which is the minimum distance in the Q region, which is 2, and dr, which is the minimum distance in the R region, which is 3. So minimum of 2 and 3 is 2, right? Now, what we want to see is that are there points, remember that we have not compared points in Q with points in R, right? So there can be a possibility that there is one point in Q and one point in R which are close to each other, right? So let's say this distance was, say, 2.5, okay, for example, okay? But remember, 2.5 is greater than 2, right? And hence they are not the closest pair. So I can neglect that. I don't need to actually check, or I need not check this, right? So, okay, so now let's take a band which is of length delta, which is length 2, and which is of length 2, right? So, okay, this is all out of scale, but let's neglect that. Yeah. So, the point being made is that we need to search for points only in this region. Okay, why is that? Let's say if I have a point here. Okay, let's say if I have a point here, very close to this, and I have a point here. This is in our band, right? Whereas this is outside our band. Okay, and what we are saying is we need not calculate this distance. Why? Because this is 2, right? And we add some small, let's say it's 0.1, for example. So this distance is 2.2, which is greater than our delta. So we need not, check those, right? So that's why we are taking a distance of 2 on each side, right? But yeah, as Shamit said, why not? Why are we taking delta? Why not delta by 2, right? So if it is delta by 2, let's take delta by 2. So what is delta by 2? 2 by 2 is 1, right? So let's take 1 here and 1 here, right? And what I'm saying is I need to only search for points in this region, right? So can you think of a counter example?
Yeah, sir, there can be a point right on the edge of the line. So that in that
Here,
case,
this one, here. Yeah, the same example, no? Let's take this example, right? How much is this distance? 1. Remember, this is in Q, this is in R, right? This might be some, say, 0.1 and this might be 0.1, which is still 1.2. And actually, this is less than 2. And actually, these are the closest pair of points. But we have not considered this because it is outside the boundary. In fact, we should consider this, right? That's why the band has to be expanded to include delta, or the minimum of the two on both sides. Okay, is that clear? All right. Okay, and now the question can be that, will there be many points here? Let's say if there are 100 points, will it be the case that 99 points will be in this region? What do you think? Then what does that mean? We have to do a pairwise comparison with all of them, right? Sorry. Yeah. And the point which is made in the lecture is that, there won't be many points in this region, right? Why? Yeah. So, yeah, this is what you all have to intuitively understand. Yeah. So, what has been done is, so now we are focusing just on this band, okay? Because that is our, this is our area of interest, right? This is our area of interest, okay? Because we want to do comparisons. When we merge, we just want to do comparisons with uh, in this region, right? Okay, so yeah, so this is that region which we have just zoomed in, okay? And what we do is we divide this region, deltas, right, into squares of delta by 2's. Okay, this is delta by 2, this is delta by 2, delta by 2, delta by 2, right? Okay, now let's say we have a point here. Okay? Let's say this is okay. Now, one question is, can I have, is it possible? Okay, let's take this as the Q region and this as the R. Okay, in the Q region, can I have 2 points in a box?
No, sir.
That is the okay, Viraj. Why do you think so? Why this is possible? No, I can have 1 point here and 1 point here.
Because, sir, the delta thing we are calculating after calculating all the distance between the point on Q side. So there cannot be like 2 points on Q side which have distance less than delta.
And is this is less than delta, you're saying?
Yes, sir. This is because the sides are delta by 2 and delta by 2.
Okay, so you're saying, yeah, so this is delta by 2 and this is delta by 2. So if I have a point here and a point here, so what is the distance between these two? This is the another thing. This is the maximum distance possible in this square. Like if I wanted to put 2 points in a square, this is the maximum distance which is possible.
Yes, sir. End of the diagonals.
End of the diagonals. And right, by Pythagoras, we know that it is square root of the sum of the two. Yeah, which is
Delta by root 2.
and delta by root 2 is delta by root 2 is lesser than or greater than delta?
Lesser than, sir, of course.
Right? So remember, the argument is this is not possible. Why? Because we already know that among all the points in Q, right, the minimum distance is delta. Right? We can't have a point which is lesser than delta. Sorry, we cannot have 2 points in the same region which are lesser than delta. Okay. So this is good. So we know that in a box we can have only 1 point. Okay, so let's draw something like this is 1 point. This can be here. This can be here. Something like this, right? So now let's say I want to compare this. Let's say a point in this box, right? And remember, I need to just check if it is lesser than delta, right? If it goes above delta, then I need not check at all because that's all that I want, right? And remember, this is delta by 2, this is delta by 2. Okay. So now can you tell me within Q? Okay, so now we know that within Q there aren't any points which are lesser than delta, but there can be points in R. Okay, this can be checked with, let's say, something over here, right? And so let's say we had a point here. So this distance, right? This is definitely less than delta, right? So we need to compare such points. Now the question is, okay, the question which we want to see is, let's say I remember that we are writing an algorithm for this, right? Looking at it visually, we can say, okay, this and this are close and all of that. But and what will an algorithm check, right? What the algorithm should do is take each point in this band, right, and start looking at, let's say, each square. Okay, we know that in each square only one point will be there. Start looking at each square. Okay, this is a very simple algorithm. Start looking at each square. So I look at this square. Sorry, not at each square. More concretely, what I'll do is I will take each point, right, and start looking at some points in that array. Remember, we had an array called QY. Sorry, we had an array called PY, right? So I will look at, so now for this, I will start looking at this. Okay, then maybe I will look at this, then I will look at this, then maybe this. Sorry, I will look at ascending order, right? So I look at this, followed by this, followed by this, followed by this, this, right? I will go up and start searching whether its distances are less than delta. But remember, these includes points in Q as well, right? We can neglect those, but let's say we are not neglecting those, right? And it can include points in R as well, right? Now the key thing to remember is, okay, this is delta by 2, this is delta by 2, so this is delta. Okay, this distance is delta. Okay, and let's say this point was here, right? And this distance is delta. So in a way, right, we need not check a point which is here. Okay, are you all getting confused? Let me make it clear. Mm. Yes, Bipin, I know you're confused. Sorry about that. Okay. This point that, okay, there can only be one point in a square of size delta by 2 and delta by 2. Is that point clear for everyone? Is there a doubt on that? Does anyone have a doubt in that? Okay. Okay. The key thing to note is that, okay, why it's not possible to have, yeah, why, Shamit, why we are checking same side point? We need not check. That's a completely valid thing. Okay. Yeah, Viraj and Shamit, yeah, I'll come to that. That's a good point. Yeah. So, okay, now we know that in each of these boxes in Q and R, okay, we cannot have 2 points in the same box. Why? Then the distance would have been delta by 2. But we know that it cannot be because all the points in Q should have distance less than or equal to delta, right? So if that is the case, right, now I need to find, remember my main goal. My main goal is to start searching for these distances, right? Okay. Now, what I will do is I will go in this direction. Okay. So let me start labeling. 1, 2, 3, 4, 5, 6. Yeah, I'll just label this 7, 8, 9, 10. Oh, sorry. 10, 11, 12. Now, okay, can you all tell me should I compare one with all the other points from 2 to 12? Is it necessary? And which points do you think it is sufficient to compare it with?
Sir, right side point we don't need to compare. On left side we can compare with 2 and 5.
Okay. So you're saying we need not compare with 3. Okay, we need not compare. We need not sorry. We need not compare with 3, 6, 7, 12, right? Why?
Because they are on same side, like on the right side
Yeah.
of the line.
Exactly. Right. So we know for sure that the distance between 1 and 3, 1 and 6, 1 and 7, or 1 and 12, it's definitely greater than or equal to that. Now, okay. But now if you want to now think of, you are writing the algorithm. Okay. if you're writing the algorithm, see, visually you could say should not compare with 3, 6, 7, and 12, right?
But
Now,
when we write the algorithms, they will occur in the py list. So we have to compare them also, right?
they will occur in the py list, yes. But then you can do an optimization saying, look at point 3, right? Look at its x coordinate. If it is, and if it is less than this, that means it is in Q. It is in Q. Or if it is greater than a particular point, we know it's in R, right? So we need not compare.
Yeah, we can compare the x coordinate with the x coordinate of this line, the separator line.
Exactly.
Yeah.
But the point is, we still have to access point 3, right? It's not that we can completely neglect point 3. We go to point 3 and then we decide whether we need to compare it with 1 or not. Is that point clear?
Yes, sir.
Okay.
So I have to ask one thing.
Yeah.
So one thing is clear. So we are not comparing points within R and within Q, but we have to cross compare them. That is clear, right?
Yeah.
Now the question that we are discussing is which points within Q and R we should be comparing, right?
No, the point which I was making is, see, visually we know that one shouldn't be compared with 3 and 6 and 7 and 12 and all of that, right? But when you write the algorithm, you will anyway encounter 2, you will anyway encounter the point 3. Then you can decide whether you want to compare it or not. Is that point clear?
Because Bipin, we have to compare all the points because all the points are in the py list and they are in sorted orders. So we have to compare every point. Algorithmically.
Yeah. We will encounter each point. So for example, this is py, right? So, and let's say we are in point 1. So 1 has to be compared with 1 has to be compared. So then from 1 we go to 2, from 1 we go to 3, right? From 1 we go to 4, from 1 we go to 5. Right?
Yes.
Then when we reach 3, it is our choice whether we want to compare 1 or 3. Okay, we can choose to not compare 1 and 3, right? Now the question is, let's say there were 100, let's say our n was equal to 100, okay? And let's say there were 100 points. Okay, let's assume there were 100 points in this band. Okay. Then it is back to square one, right? We are comparing 1 with 2, 3, 4, 5, 6, 7, 8, 11, 12, up to 100. Then we'll compare 2 with 3, 4, 5, 6, up to 100. So then it is reducing to an n square algorithm again, right?
But sir, that depends on our input size. Like what is the input size? Like if it is very greater than 100.
Okay. But remember one thing, okay, when you are going up this y direction also, remember what is this height? This is delta by 2. This is delta by 2. So let's say you have a 1 here, and remember, see your points. Yeah, 0.6 or okay. Now let me take another example. Let's say a 0.7 instead of here. No, it was somewhere here. Okay. And now I want to now let's say you have done some comparisons with 1. Now I want to compare 2 with all the points above it, right? Now, I'll compare 2 with 3, with 4, with 5. Now, my question is, can we say after a particular point, I do not want to compare. I need not compare 2 with points above a particular threshold. Right? This is delta by 2. This is delta by 2. At this point from 2, right, this much distance is delta already. Right? So any point above this line or slightly above this line, even if it is in R, we know that its distance is greater than delta. Okay, I'm reiterating this point. Any point, which is 1, 2, let's say 1, 2, 2 squares above a particular point. We know for sure that its distance is greater than delta. So we need not compare it with any of the points 2 rows, if you can say, right? 2 rows above that point. Is this point clear?
Yes, sir.
Sir, I have a doubt. If the 2.2 is in the same box and slightly up, not in that exact point, instead slightly up, not
Yeah.
across the box also. Okay, then I think 2
Wait,
and 7.
okay, sorry, sir. Yeah. Oh, you're saying somewhere here.
Yes, yeah.
Okay.
Then 2 and 7, sir, make smaller
Yeah,
distance.
so we are considering above 2 levels now, so that will be okay. 7 is
No, no,
very
yeah, I understood your point. Yeah, so this is still in this box, and 7 is, yeah, I got it. So 7 is in the same box, right? And their distance is definitely less than 2, right? Sorry, less than delta. So we should consider that. Correct.
I think, sir, it should be not 2. I think it should be 3 for the most accuracy.
Okay, that's a good point.
Sir, how many boxes are you considering?
Yeah, so actually there are different interpretations. Some say you can consider 2, some say you can consider 3, but the safest I would say is to consider 3, and that's what I think Sir has also done.
So sir has taken around 16 points, next 16 points basically.
Yeah. So next 16 points is how many?
Next 15 points meant next 15 boxes, right? Because we can have only 1 point in one box.
1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So let's say there is 1 point here. At the most, you need to compare it with, this is how many rows? Like 1, 2, 3, 4 rows. But I believe you need not, I think you can cut it up to here. Right?
Yes, sir.
Right? So let's think of counter examples. No, let's see if it's possible. Yeah, sorry, who was it? I think it was who gave an example. So we have a point here, and we have a point here. No, or so this is delta by 2. This is delta by 2. We know for sure if there is a point over here. There is a point over here. Should this point and this point be compared?
No, sir.
No, sir.
Okay. So, and this is how many boxes away? You can see like that. So this is 1, 2. So if this is 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, yeah, 15, right? Yeah, so I think that is the reason why. Remember, this box has been that and 16. So there are, in each box, there will be 1 point. So at the most, we need to make 15 to 16 comparisons.
Sir, 12 will be enough, I guess.
Okay, what about in this case?
In this case,
Uh,
also, if we can take the point from 9, like 8, 9, 10, 11, like if we go in 12, 13, 14, 15, that distance will be greater than delta only.
Yeah. Right. All right. So in short, let's come to the bigger picture, no? So let's say there is 1 point, all these points are there. From 1, we just need to check up to the 15th point in the worst case, right? From 2, we need to just check up to the 16th point, like whatever, right? This point. From 3 up to the 17th point, okay, at the max, right? So remember, this is not proportional to 3, it's just a constant addition, right? So at the most, we have to just search for 15 more points ahead of a particular point. So instead of, like we said, array, how much should we search? So from a particular point, just look at the next 15 points. You are sure that, and if the distance is less than delta, then you can be sure that that will be the new minimum. Anything above the next 15 will not be greater than delta, so you can ignore. Okay, is this clear? So your comment had a doubt. Okay, Snail is asking, so we are saying that we will have to look at every point. We will have to look at every point at least to check whether they're on the same side of. So the point which is being made is actually we need not check. We need not do that additional check also. Even if it's in the same. So even if it's in the same point, in the same side, we know for sure that its distance is less than or equal to, greater than or equal to delta, because we have already checked that. So we need not do that additional check of checking whether it's in Q or whether it's in R. We can straight away look at the next 15 points and check if it is less than or equal to delta, and we'll be done. Okay, Viraj is saying, yes, we have to check. We can improve this part by applying some condition. Yeah, Viraj. What do you mean by that?
So like you said, we can use that thing, like we can compare the x coordinates.
Yeah, we can. See, but yeah, definitely you can do that also. See, what I'm saying is, let's say, okay, now let's say we are in point 1. Okay. Now, according what I'm saying is, now when we reach point 4, one thing which we can do is check, whether 1 and 4 are in Q, and if they are not, if they are in Q, then don't compare 1 and 4 at all, right? That's
Yes,
what
sir.
you're saying, right? Same thing with 1 and 5. If 1 and 5 both are in Q, don't compare them, right? But what I'm saying is, even if 1 and 4 are in Q, and even if we compare them, it won't cause any problems, right? Because we know for sure that 1 and 4 and 1 and 5 are greater than delta, or whatever they are, right? So in your algorithm, you actually, so checking whether it's in Q or whether it's in R, it's an additional if condition, right? It's a step. Yeah, that's why we are comparing next 16 points irrespective of the sides in the algorithm. Correct. Okay, so what about the others? Are you all confused? Uh, you know, are there any doubts? So the whole point of this exercise was this 15-point thing is within a particular, within two bands, right? Q and R, right? You need not check all of the points in this band. You just have to check for the next 15 points for each point. Okay. So this is just for you all to be, satisfied that we need to just check for the next 15 points. Okay, Bipin is asking if the point is in box 1, even box, yeah, box 12 to 15 need not be compared at all. Yes, that's true. I think Sir has taken 15 as, a very safe estimate, right? But yeah, up to 8 will also. And we don't need to check all 16 if we check the sides also. Yes, that's true. Okay, so all this we did. Yeah. Okay, so the pseudocode, this is the base case, right? If it is less than 3, we just compute pairwise and return the distance, right? Then what we, otherwise what we do, we construct this QX, QI, RX, RY. Okay, so let's go back to this. Let's see. Yeah. Okay. So remember we had 1, 1, 2, 3, 3, 4, 5, 7, right? What we did is, length of px is, yes, definitely greater than 3. Then what we did is we constructed a q and we constructed an r, right? That is, there is that. Right, this thing, right? Qx and r, q, yeah, we constructed qx, qx, qi, rx, ry, right? And on this, again, we call the closest pair on qx, qi and rx, ry on this, right? And for this example, q had only 2 points, r had, sorry, q had 3 points and r had 2 points. So in the next call itself, they are returning, right? Q1, Q2, R1, R, right? And DQ and DR, right? The minimum. In this case, it will return 2, and in this case, it will return 3, right? Now I have to now we know the minimum in Q, the minimum in R, but there is a possibility that there can be a point in Q and in R, right? Which is whose distance is minimum, right? So that what we do is we construct a new SY, right? And that is actually, yeah, from QI array. Remember, we go from bottom, right? The minimum y to the maximum, and we start scanning it. And remember, we just scan for each y, we just scan up to the 15 or 8, whatever you want, the next 15 or the next 8, and we find the minimum ds, right? So ds is the new, like the minimum amongst one point in q and one point in r, right? Q and r may, which is the minimum. It can very well be that, the minimum is greater than q or r. And in that case, we are just returning the minimum from dq, minimum from dr, sorry, minimum from dq, dr, or ds. And that is the algorithm.
Sir, can you again explain this algorithm, pseudocode?
Okay. So yeah. So have you understood the base case?
Yes, sir. It means if the length of the each pairs are less than 3, then we should compute and return the closest pair. Means the minimum distance point, right?
Exactly. Yes. So let's take these 3 and okay. So let's take this. So there are 1, 2, 3, 4, 5, 6. So length of this is our p, right? And our length of px is greater than 3. So now we will construct this qx, qy, rx, ry based on this example, right? We just look at px, py, and based on that we construct this rx, ry, right? And what we'll see is that qx is here, q is here, and r is here. Qx are the points, x coordinates of points in here. Qy is the x coordinates of points in here, and similarly for r. Is this clear?
Yes, sir.
Okay. Now we do the divide and conquer, right? Now for q, we again calculate the closest pair, right? If there were many more points, we would have divided it again, and this becomes the new q and this becomes the new r. And we keep on doing this, right? And similarly, so now this again we call here, and for this again closest pair is called, and now our qx qy is actually now the qx qy becomes the new px py, right?
Sir, what is QI again, please?
Oh, okay. So qx qy is the points which are there, the x and the y coordinates of the points which are there in the q region.
No, sir. QX is like the points sorted in according to the x-axis.
Yeah,
And
yeah,
Y
sorry.
is-
Yeah, yeah. So if we go to this example, remember this was my points, no? 1, 1, 2, 0, 5, 1, 1, 2, 3, 3, 4, 5, 7. Now I divided it like this. So how did I divide it? I know px. Px is nothing but the points in P. It's the same points, but I sorted it based on the x-axis, right? Increasing order of x-axis. Py is the same points, but I sorted it based in the increasing order of the y coordinates. Right? The
Okay.
same thing. Qx is also the same thing. Just for that region, the Qx is nothing but the points sorted according to the x coordinate. Qi is the points in Q, the same points, right? 1, 1 is already there, 2, 3, and 0, 5. Sorted according to the y coordinates. Is that clear?
Yes, sir, clear.
So we keep on doing this. We can keep on calculating Qx, Qy until we get, the base case of less than or equal to 3, right? And we get something. So let's say that point is this one, right? This is say Q1, Q2. No, sorry. Okay, let's say that minimum distance is, okay. Let's say that minimum distance is this, right? Which is between point Q1 and point Q2, and the distance is dq, right? We got that. Now we call, we do the same thing for Rx, Ry, right? Again, this is called, we compare the distance, and let's say this is the distance which we get, R1, R2, and the minimum distance is dr, right? So in a particular region, we have found out the minimum distance, right? That is this one. Now I have to construct this, new set of points Sy from Qy and Ry. Okay. So I will take this point, right? I will compare it to, that has not been mentioned. I will compare it with the next 15, at most 15 points. So I'll compare it with this, 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 right? And like that, I will compare each point within within which are at a, I'll compare each point with the next 15 points. That's it. Or the next 8 points. That's it. So, and let's say when I one by one I do that, right? I might get, I might compare this Q1 with R1, and I might get that as the minimum of, all the comparisons in S. Right? So now I have dq, I have dr, I have ds, right? And I compare which of them is the minimum, and that is the closest pair in the whole graph.
Clear.
Okay. I hope you all have at least got the intuitive idea about, how it's working. Okay, so can we move on? Is there any doubts in the closest pair?
I mean, I had a question, Prajesh.
Yeah.
My question is, even in this algorithm, you are basically comparing every point with every point to calculate the distance, right?
For
between points, you have to compare every point with every other point, isn't it?
To calculate Sy, you're saying?
No, to calculate distance between any 2 points.
No, for example, we were,
Oh no, so you're saying we are only comparing points within Q
yeah, yeah,
separately and within R. So that way we are distributing the work.
yes,
So,
yes,
so we are not comparing any point between Q and R, except those which are at the border.
which are at the
So,
bottom.
so which is why this is more efficient. Okay, I get it. Because I thought ultimately we would be comparing every point with every point. And so why would this be more efficient than the original naive thing? But here what we are doing is we are only comparing half at a time. And okay.
Yeah,
Right,
and
okay.
within borders also, within a particular distance of minimum of DQ or
Yes,
DR,
yeah.
we
So
are
that is where
just
the
calculating.
efficiency is.
Yeah.
Okay.
All right. I hope that is clear. Okay. Okay, what do we have little time left? Yeah. So I can do one of these things, median of median or Karatsuba. Like, what, is there a specific doubt in either of these? Complexity. Okay, okay. Complexity or median. Okay, let's go to that. Yeah. So the main reason to calculate this median of medians, right, is to find a good pivot quickly, right? And that is where the efficiency of the algorithm lies, right? Even in quicksort, you all saw that if we choose the pivot, the array can be, if we always choose the pivot such that the length, like it becomes, let's say, n-1 to the left and nothing on the right. So then it will take an n square uh, time to run, and that is inefficient, right? So what we are doing in this median of medians is we are dividing our length into blocks of 5, right? And we find the median of each block. And then on this M, we again to calculate the median of that block, right? So let's say we have a list L, right? Base cases, if it is less than or equal to 5, right? We know that we just sort it and we return them, right? Sorry. Otherwise, what do? We look at the list, right? And in steps of 5, right? And we take the median, right? And then we append it to this list. And then we recursively call MOM until we get one with length 5, right? Less than or equal. So if you see in this, yeah. So here, let's say these are the blocks, right? It is, yeah. So let's say we have these blocks of 5, right? And what we do is we are calculating the median of each, right? And of all of these, we are calculating the median of that, right? Which is this block, right? Now, yeah. So now the question is, why is this efficient, right? Yeah. So yeah. So let's look at this. This is the median of medians, right? So what? Yeah. So what we can what we can tell is for sure that this block median, okay, so it lies between, yeah, so how did we get this 3 length L by 10 and 7 length L by 10? So this is, yeah. Yeah. So if we give these, yeah. So here you can see that this, right? This is greater than all of these values, right? This blue box is greater than all of these values, right? And it is less than, okay, these values, right?
Sir, are you writing anything?
No, I'm not. I just highlighted some. Can you see this, what I'm doing?
Yes,
Is my
sir.
screen visible?
Yes, sir.
Okay. Right.
And sir,
So,
the,
yeah, Shubha.
what about the rest, sir? Is there a equal?
Is there a?
Equal? You mean the upper one is the greater one, right? And the lower one is smaller one from that blue box. You
Correct. Yes. Sir. Yeah.
What about the other two halves? Other two quarters?
Yeah. So, what do you all think? Can you tell me something about this? So anything to the right of this is greater than this, right? Sorry, I again mistaken. Anything? Do you all agree? Do you all agree that this, anything to the right of this is greater than this? Okay, I should have considered this. Sorry about that. Okay, so basically what this is saying is this median of median, right? Let's say this was our entire list. Okay. Sorry. Right? This is less than, sorry, this is greater than this part and it is less than this part. Do you all agree with that? So then what is this fraction? So let's say it's our big list was there, right? By doing this median of median business, we have found a median of medians, something which is dividing our entire list, okay, into two parts. right? And what are these fractions? Can you all visualize what it looks like?
3:7.
Okay, how did you get that?
Counted.
Yeah. Right. So whatever, by doing
Mm,
this median,
If one is 3 means the other is 10 minus 3, 7. That's
correct. So by doing this median of median things, right, we are able to get a pivot, right, which will divide our list into 3 tenths and 7 tenths, right? And because of doing that, by doing that, we are able to, sorry, yeah. Snail, what are you saying? Why are the ending nodes of the column before the median column larger than the, yeah, it need not be the case, right? You are talking about, sorry, yeah, these points, right? Snail, are you talking about this? Yeah, yeah, I'm sorry about that. Yeah, it need not be. Need not be. Yeah, that's yeah. So yeah, so that's the reason why it will lie between 3 tenths and 7 tenths, right? If it is greater than all of this, then we can definitely say it is 7 tenths, right? Otherwise, at least 3 tenths of the total length, it is between them, right? Yeah,
oh, so it's not exactly at the 3:7 point. It is in a some range.
yeah. It is
Goes
between.
from 3/10 to 7/10.
Exactly. Yeah. Right. It is between that range, and since it is between that range, we know that our quick sort, the partition, will partition our set or our list, uh, into a roughly equal proportion. So, and in that way, we are the even in the worst case, right? It won't be order of n square. Okay, Snail, how can you tell me how you understood 3 tenths? Then maybe I can. Snail, are you there? Because we can reduce that the median. Sorry, yeah. So the median is always bigger than or equal to at least 3 tenths of the values in the list, right? Because there are only 5, right? Now, it can also be the case that this median is so it can also be the case that this is greater than these as well. So, for example, right? So this much is 5 tenths. So 1, 2, 3, and 1, 2, 3, 9. Sorry, how much is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So what is this fraction? I'm not calculating it now. Are we making these groups of 5 after sorting the list of? Yeah, so after sorting the list, right? So I'm talking about the, the bounds. The upper bound is, it can be the case that this is greater than all of these, right? Sorry, this is lesser than all of these. Then the ending blocks of all the columns to the median left must be smaller than or equal to the median. So within a particular block, they are sorted, right? It need not be the case that amongst blocks they are sorted. So let's go back to this. Each block of 5 is arranged in ascending order, top to bottom. Block medians are the middle rows. So this is sorted. Yeah, but we cannot say anything about the adjacent or any of the, any, let's say ith. So we cannot say anything about this versus this, right? The relationship between any of the blocks. We just know that each block of 5, each of these blocks are arranged in ascending order. Yeah, the blocks are sorted, but not the entire. Yeah, sorry, I didn't make that very clear.
Sir, are they sorting the entire list first and making the blocks, or first they're making the blocks and sorting the blocks?
Yeah, sure.
They're sorting the blocks only. They're not sorting the entire list.
Yeah, we're not sorting the entire. So here you see that we are just taking blocks of 5, sorting it, calculating the mean. All right. We are almost out of time. Karatsuba's algorithm, I believe Atul yesterday he explained it in the session. Any specific doubt you all have regarding Karatsuba? So one suggestion can be you all might get confused, with a binary thing. Try it out with a decimal. And I think Atul also gave an example of the decimal case, right? Try to work it out with multiplying uh, 2 decimal numbers, then you will get it. This one, right? Yeah. Okay. Okay. Any other doubts? Anything else? Okay. If there's nothing else, then we can end the session.
Sir, are there more efficient algorithms than Karatsuba for multiplication?
I don't think so. No, because even what was mentioned in the lecture, no, like uh, for a long time it was thought that it can be done only in quadratic time. right? But as far as I know, I don't think, yeah, there are improvements. Yeah. All right, everyone. See you all next week then. Okay. Bye.